Okay, so good morning, good afternoon, or good evening, everyone. Kung anong oras nyo ba ito mapapanood itong video. So, in this discussion, we're going to discuss the three different propagations that are being used for the communication of an aircraft. So, we have there the number one is ground wave, number two is the space wave, and number three is the sky wave. So, what are the difference of these three? That will be tackled here in this video. So keep watching so that you will learn anything or something in this video. So first is our ground wave propagation. So what is a ground wave propagation? Ground waves tend to be held near the Earth's surface and bend with the curvature of the Earth. So sabi dyan, ang ground wave daw natin is a way of propagation or a way of communication which is yung ating frequency is it tends to bend or follow the curvature of the Earth. So kung meron kang building or kung meron kang mountain dyan sa harap, using ground wave propagation, ang mangyayari dyan is dadaan po yung mismong frequency natin in that mountain or in that building. Kahit gaano kataas yan is tataasin po yan ng ating ground wave propagation. Ground waves travel a distance limited by the transmitter's output power, antenna design, local terrain, and current weather conditions. So ang ground wave daw natin is being affected by the transmitter's output power. Kung malakas ba yung output power ng transmitter mo, and the output power of transmitter is being measured by watts. Okay, so sabihin dyan, either 100 watts, 200 watts, 300 watts, that is the output power of your transmitter. Antenna design, kung masyadong mahaba yung antenna mo, masyadong maliit, manipis yung mismong antenna, or makapal yung antenna. Local terrain is kung masyadong mabundok, or kung sakaling masyadong maraming building, is affected po yan, no? Or isa siya sa mag-affect dun sa ating ground wave. And also our current weather conditions. Kung sakaling masyadong mabagyo, masyadong snowy, masyadong mahangin, o masyadong mainit, it will also affect the communication of the ground wave propagation. So typically, a relatively powerful transmitter is capable of sending ground waves a distance of 1,000 miles. That is the maximum distance to be traveled by a ground wave propagation. Okay, so for a powerful transmitter po, ibig sabihin mataas ang ating output power ng iyong transmitter. But kahit gaano kataas yung ating transmitter's output power, the maximum distance to be traveled by the ground wave is only 1,000 miles. Next is our sky wave propagation. So what is sky wave? Sky waves tend to travel in straight lines but may also be reflected off the ionosphere layer in order to reach the receiver. So ang ating sky wave is pwede siyang mag-travel straight lines or in the line of sight, no? But it can also be reflected off the ionosphere layer in order to reach the receiver. So pwede siyang umakyat sa ating ionosphere, then it will bounce back to the receiver. Because of this method, the sky waves may produce a skip zone where no reception is possible. Kung sakali man na nangyari yon na umakyat siya or nag-reflect siya dun sa ionosphere, isa mangyayari dyan, para siyang gagawa ng arco. So, ibig sabihin, yung sa loob ng arco mo na yon, doon ang tatawag natin na skip zone. Don't worry kasi meron na ipapakita sa inyong picture mamaya which will be explained further or elaborated further. Neither the line of sight nor the reflected wave can be received in the skip zone. So pag sa skip zone natin daw, hindi daw makakapag-receive ang ating receiver either kahit line of sight yan or reflected wave. Pag sinabi natin reflected wave, that is yan na yung dumaan dun sa ating ionosphere. Yun yung na-reflect ng ating ionosphere. So kahit man sabihin natin na line of sight yan or reflected wave is hindi po yan marireceive ng ating receiver pag dumaan siya sa skip zone. So yan. Ang ating sky wave propagation is meron po siyang dalawang characteristics. That is your skip zone range and your multi-hop propagation. So what is skip zone range? Yung skip zone range, kung sabi natin, is yun yung zone kung saan nagkaroon ng arc o kung saan hindi ka magkakaroon ng transmission or receiving ng ng communication or ng frequency. Multi-hop propagation will be discussed on the further slides. So yan. A skip zone, also called the silent zone or zone of silence, is a region where a radio transmission cannot be received. The zone is located between regions both closer and farther from the transmitter where reception is possible. Yan nga sabi natin, paulit-ulit na lang yung sinabi natin sa skip zone is that is a region where a radio transmission cannot be received. So kapag andun ka sa skip zone na yun, hindi ka po makaka-receive ng any transmission or radio transmission. So ito yung sinasabi ko na skywave radio waves refracted in the E and F layers of the ionosphere, maximum 1 hip skip distance about 2,500 miles. So dito, ang sinasabi natin kanina na yun, na skip zone is this one. From this point, kung asan nagkaroon ng sender, until this point, kung asan yung receiver natin, ang tawag natin dito, from this distance until this distance is your skip zone. So, ibig sabihin, in that skip zone, wala po tayong makukuhang transmission or any radio transmission. Ibig sabihin, silent po yan. Wala ka pong makukuhang any transmission. Pag nangyari is nagkaroon tayo ng skip zone. No? Na pag line of sight yan, pag sinabi natin line of sight, dire-diretso yan. Okay? Pero, pag nagkaroon tayo ng skipping, from this point until this point, wala pong communication yun. Wala kang makukuha na transmission. Yung sinasabi naman natin na one hop, yung hopping skin, yung one hop na yun, ito, maximum one hop skip distance about 2,500 miles is from this point until this point. Ang layo po niyan is 2,500 miles. So, within that range, wala ka pong makukuha dyan na receptions. Yan, skywave propagation. Signals are bent back to Earth by the ionosphere. Ito yung sinasabi natin na multi-hop propagation. Multi-hop propagation. Okay? Ilang beses siya mag-hop from the sender, ionosphere, back to Earth, ionosphere, back to Earth, ionosphere, then to the receiver. Yan po yung sinasabi natin na multi-hop propagation. So, multi-hop propagation has a radio signals bounce several times between the ionosphere and the Earth's surface. So within this point, until this point, that is your skip zone, which has a distance of 2,500 miles. This point until this point is the same din po, 2,500 miles yan. And this point until this point is also the same with a distance of 2,500 miles. So yan po yung dalawang characteristics ng ating skywave propagation. Meron siyang skip zone and kayang-kayang mag-multi-hop. Skywave propagation range is much greater than ground wave propagation. Bakit kaya? Bakit kaya na mas malayo daw yung range niya? It is because itong multi-hop natin. Kaya mas malayo yung range niyan. Kasi 'di ba yung sa ground wave natin, yung pinaka maximum distance niya is only 1,000 miles. Remember dito sa skip zone natin pa lang, luging-lugi na yung mismong ground wave natin. Bakit 2,500 dito eh? From the transmitter, tapos ang susunod na bound na hop niya is 2,500 miles lang yung layo. Okay? So yan, skywave propagation least often occurs in the UHF frequency range or the ultra high frequency range. Okay? So yan, pwede ka lang gumamit ng skywave propagation pag yung transmitting frequency mo is within the range of the ultra high frequency range. Yan lang po, diyan ka lang po pwedeng gumamit ng skywave propagation. Last is our space wave propagation. Space wave frequencies have a short wavelength which allows them to penetrate the ionosphere. Because of this, space waves are limited to line of sight reception only. This method is used to communicate with satellites or the satellite communication and your GPS or the Global Positioning System. Okay, so ginagamit lang po natin itong space wave in the line of sight reception lang or the line of sight communication lang. And remember, maliit lang ang kanyang wavelength. Di ba ang sabi natin sa wavelength, that is the max, that is the distance to be traveled by a certain frequency. So, ibig sabihin, the shorter the wavelength, ibig sabihin, the higher the frequency. Tama? Kasi the lower the frequency, the longer the wavelength. But, the stronger the frequency, the shorter the wavelength. Okay? So, dito, kung mapapansin nyo dito, space wave yung gamit-gamit natin from the antenna, from the transmitter to the aircraft. So, bakit tayo that is space wave ginagamit natin? Line of sight po kasi yan. Okay, so kayang-kaya natin yan. Ibig sabihin, pag space wave din yan, mataas yung ating frequency. Malakas yung frequency niya kasi nga short wavelength lang siya. So, ibig sabihin, pag mas mataas yung frequency mo, mas maliit ang tendency na magkaroon ng chop or yung choppy na hindi mo nagkakat yung communication or napuputol yung communication. Maliit ang tendency niyan. Bakit? Kasi mataas po o malakas yung ating frequency. Okay? But for the skywave, pwede tayong gumamit ng skywave if ever lang talaga na masyado ng malayo. But for the communication of the air traffic control or the ATC, papunta sa aeroplano, gumagamit po tayo ng space wave propagation. Yan. Ground wave propagation is masyadong ginagamit natin yan kadalasan sa mga cellphone lang natin. Okay, cellphone lang tayo gumagamit ng ground wave propagation. But for the internet, kung sakali, diba, to messenger na, no, Facebook, or whatever, gumagamit tayo ng skywave. Bakit? Para mas mabilis na makarating yung ating message dun sa kabilang bansa, kung sakali man na ibang bansa yung chinachat mo or kinakausap natin. So, yun lang naman. If ever na may questions tayo, is you can comment down below in the comment section, then I can entertain it in our Google Classroom. So, yan. Thank you for listening.